Okay, pre-calc, how are you today? We are going to take some notes on polynomial functions. I am giving you a polynomial function, f of x, and I'm going to ask you 4 questions about the same function. The first question is, I would like to know where, let me see, I'll just mark number 1 for question number 1. I want to know where is f of x greater than or equal to 0. So I want to know the x values, the domain intervals, the x values, for which the y values are greater than or equal to 0. F of x and y are interchangeable, so I'm looking for the places on the x-axis or the x values from negative infinity to positive infinity for which the y values are either on or above the x-axis. When the points are on the x-axis, that'll take care of my equal sign. For instance, this negative 6 is really negative 6 comma 0. So you can see that 0 right there. That's where y is actually equal to 0. Same thing with the negative 2 comma 0. Whoops, sorry. I was going to write the whole point over again. So negative 2 comma 0. There's your 0 right there in your y coordinate. And then again 3 comma 0. And there's your y coordinate of 0. So for those points that are on the x-axis, I definitely want to report them in my answer. Make sure they're included as part of my answer. Additionally, I want the x values for which the y values are above the x-axis. So I'm going to choose a highlighter here. I have a green highlighter. And I'm going to make sure to include that negative 6, that negative 2, and that positive 3 with the answers that I'm going to write down here in my answer box, okay, on my answer line, so to speak, as well as those points on the x-axis. Like I said, I want the points where the graph is above the x-axis, above over here as well, and above over here as well. So pretty much any of this graph, as long as I'm going from negative 6 to the right, I want to have as an answer down here where my y values are greater than or equal to 0. So I'm going to start with negative 6, and I'm going to include negative 6 because negative 6 is on the x-axis, and I am going to go all the way to positive infinity. Every x value between negative 6 and positive infinity has a y value that is greater than or equal to 0. And that ends this question. Let's move on to question number 2. So here is number 2 right over here. Same exact function, but this time I want to know where is f of x less than or equal to 0. So I want to know where is the y value less than or equal to 0. And because I'm saying equal to 0, I can be on the x-axis, but when I say less than 0, I now want to be below the x-axis. So let's do the same thing we did with our highlighter here. Let's choose this highlighter, and let's indicate that we want to make sure to include the negative 6, the negative 2, and the 3. And now I want to, that's going to take care of the equal sign, right? And now I want to go below the x-axis. So below the x-axis, the only thing below the x-axis is over here. And I'm going to highlight that arrow as well. I'll come back to the first one. I'll highlight the arrow too. That's kind of a good idea to do that. You'll see later on as we get different arrows that are a little more confusing how it becomes helpful to have the arrow highlighted. Anyway, for this question here, this arrow indicates to me that I'm looking at something going left forever and down forever. As x goes further and further and further to the left, my y's go further and further and further down. And again, I'm kind of labeling this arrow here. It's kind of weird, but that's what I want to do. And which tells me to use this negative infinity right here as my x value to begin this problem. Negative infinity all the way to, let's see, I go all the way up until I hit 6, and I include 6. So I'm going to hit 6 and put a bracket there saying, nope, negative 6. Include that negative 6. However, I'm not done because I've got these 2 little points here. This negative 2 all by itself So we're going to say union. We're going to open a bracket, write -2 comma -2. That's how I indicate a singleton value. Start at -2 and include it. Stop at -2 and include it. I got to do the same thing for the value of 3. 3 is all by itself. So open bracket, 3 comma 3, close bracket. Oops, close bracket. And I'm going to extend that answer line just a little bit right there. Okay, I don't like the way that looks right there, so I'm going to do it again. Very good. Okay, now instead of including our points on the x-axis, we are going to move on to the next two questions, and we are going to not include the points on the x-axis. So let's see. This now says find, well, I didn't write the directions for that, but I say f of x is greater than or equal to strictly greater than 0 where? So I'm looking for the x values, the answer over here. These are all x values for your answer, okay? These are domain x values. Find the x values for which the y values are greater than 0. And y greater than 0 means I'm looking for anything strictly above the x-axis, which means I do not want to use that -6, that -2, or that 3 in my solution. So I'm going to put a small arrow here. I do not want to include, oops, get out of there. I do not want to include the -6. I do not want to include the -2, and I do not want to include the 3. This is how I'm indicating that I do not want to include those points, by wrapping those points in an open circle, because we know the open circle means do not include me. Okay, so now we want to go above the x-axis as well. So I'm going to highlight above the x-axis, here to here, above the x-axis from here to here, from -2 to 3, I should say, from -6 to -2, and then from -2 to 3, and then from 3 forward. This all gets highlighted. Good job. All right, and now I want to give the values on my x-axis for which I've highlighted this green on my function f. So I'm looking at starting at -6, but I do not want to include that -6, so there will be no brackets in this in any of these intervals that I'm going to give as an answer here. So open parentheses, -6, no bracket. Parentheses mean don't include me. Get as close to me as you want, but don't touch me. Comma. And now I have to go to -2 and close my parentheses, because once again, this -2 right here is not included in the solution set, just like the -6 was not. So I have to jump over the -2. And so I'm going to have a union here. I'm going to start at -2 again. And this is how let me see here. This is how I exclude -2 or omit -2 from my interval, is I close with the parentheses and I open with parentheses again. And that actually ends up omitting the -2. Okay, so from -2, which puts me here again, I'm going to continue forward until I get to +3. Once I hit +3, I'm going to close my parentheses and say I can get as close to 3, but I can't touch it. So I'm going to hop over it. This is going to be a union here. And we're going to go from 3 to +infinity. Okay, and we'll extend that line a little bit like that too. Okay, so this is the interval I'm looking for up above. And we'll see. I just thought of another strategy, and I will bring it back to you, and we'll redo 1 through 4 just real quick. Like, oh, you know what? Never did call this question 3, did I? And here's question 4. Alrighty. So for question 4, I'm looking at f of x less than or equal to 0. This means I want y to be less than 0, which means we're looking for x values for which the graph itself is strictly below, this time, below the x-axis. So this graph is below the x-axis. Let me see, anything over here is below the x-axis, right? However, the only thing on the graph that's below the x-axis is this little section over here, including the arrow. Okay, so how am I going to name that? Oh, you know what? I do not want the negative 6. I do not want the negative 2. I do not want the 3. Make sure that when you know that you are strictly below and it's not above at all and not on at all, that you go and you put open circles around those points. Make sure that you do not include those values when you answer right here. Okay? So I guess I should have done that first, and I didn't think of that first. I'm sorry. Okay, so I'm looking for my interval here. So this is negative infinity for my x. This is positive infinity for my x. I definitely am starting at negative infinity, and I always use parentheses for the negative infinity. All the way to where do I have to stop? Right there at negative 6. And I do not include negative 6. And there is nothing else for the rest of this graph that is included in my domain intervals here. So I am finished with these 4 problems. Now, let's go back to the top here. And if the coloring wasn't good enough for your final answer here, let's think about something else. Anywhere that you have coloring above the x-axis itself, you can bring that coloring down. So let's do that. Let's bring this coloring down to the x-axis. Let's thicken that a little bit. Okay. Let's bring this coloring down to the x-axis. And let's bring this coloring down to the x-axis. And since it has an arrow, I can really keep going, can I? Forever and ever and ever. So now I'm basically trying to go from negative 6 all the way forward. This whole entire area is covered. And now maybe it seems a little bit easier for you to say negative 6 to infinity, because all of this is covered. All right, let's look at this one over here on number 2. I have points at negative 6, at negative 2, at 3, and I have this section of the graph that is below, because we're dealing with on or below the x-axis. So this would be shaded up. Okay, and let's not forget, this is negative infinity over here. So if I wanted to continue shading and shading and shading, I guess I could, couldn't I? So do we see that the only thing on the x-axis that gets shaded goes from negative infinity all the way to negative 6, and then negative 2 is by itself and 3 is by itself. So you have these 3 different pieces that you have to have because my shading is broken up. Over in question 1, my shading was definitely not broken up. Okay, so I'm hoping that makes a little bit of sense. I don't want those there. Okay, let's look at question 3. We'll do the same thing with 3 and 4. Get my green back. Okay, so anything above the x-axis here was shaded green, so I can come down and I can shade my x-axis right there. Same thing here, I can shade the x-axis. And this continues to go higher and higher and higher and further and further and further to the right, so the x-axis continues to get shaded over and over and over again. Let's not forget that this is positive infinity this way. So can you tell this a little bit better here? That this negative 6 is going to match right here. It's where I'm going to start. Okay. Let me get rid of that little thing here. It says x values. Good. This negative 2 here, everything between negative 6 and negative 2 is shaded green, but negative 2 is where the shading stops momentarily. Then it picks right up again at negative 2, goes to positive 3, and then from positive 3 goes on forever and ever and ever to infinity. Hopefully that makes a little bit better sense, maybe to see the shading. Over here, number 4, there's not much shading to do. I just have this little bit of shading here. Of course, I can continue to go, right, over and over and over. So the only thing on my x-axis that gets shaded is from negative infinity all the way to negative 6. These open circles here that I have, they're basically irrelevant, but I just wanted to make sure I put them in there because we always want to distinguish whether or not we are including that 0 or not including that 0. Okay, so we're going to move on. I have another picture drawn, and we are going to try the next picture. So the squiggly means we have a different picture. Okay, well, if you'd like, you could try that yourself. We have f of x is greater than or equal to 0, f of x is less than or equal to 0. Pause the video, try it all by yourself, and then turn me back on. All right, so f of x is greater than 0. I think I'm going to pick a different color this time, if you don't mind. I'm going to go for, I like blue, so I'm going to do a blue highlight this time. Greater than or equal to 0. Y is greater than or equal to 0. The equal to 0 part means on the x-axis. The greater than 0 part means above the x-axis. So this is either on or above. On or above the x-axis. All right, back to my blue. Do I want to include the points that are on the x-axis? Yes, I do. It says on or above, so I'm going to include the -7. I'm going to include the -4. I'm going to include the 0, and I'm going to include the 5. So I have solid dots on those points that say include me, don't forget me. And now I want to shade anything above the x-axis. So I'm shading the function where it goes above the x-axis, above the x-axis. Oh, it dipped below the x-axis. I don't want to shade there. And at 5, I'm good, but then it dips below the x-axis, and I don't want to shade there. So I think I'll do my little shading here and bring this all down to the x-axis because it's the x intervals that I'm looking for. This one's kind of cool. Something cool happens here. Alrighty. Well, I begin my interval at -7, and it's a closed bracket because I do want to include that point. I do not have to stop at -4. My blue interval started at -7 and goes straight all the way until 0, non-stop, and you include that 0. And then I have a singleton point 5 hanging out over on the end that I want to include as well. So I'm going to say union, open bracket, 5, 5, close bracket. And that is that piece. Let's call this number what? 5? Let's go ahead and call this 5, 6, and of course there's a 7, 8 underneath if I scroll a little bit down. So let's go back to my shading here. Oh no, let's take my pen for a second. What is this actually asking me here? This wants to know where is y less than or equal to 0. The equal sign means on, and the less than 0 together, less than 0, means that we are dealing with or below the x-axis. So I do want the points that are on the x-axis. I'm going to put a big solid dot saying, keep me, include me in the answer. I want to be part of it. All of these points have to be part of your answer that goes down here. Okay? Alrighty. So I also want to possibly be below the x-axis as well. So anything below the x-axis, this is below the x-axis with the arrow. We have something else below the x-axis over here. And after the 5, from 5 to infinity, we have below the x-axis as well. So I'm going to take those sections actually that are below the x-axis and I'm going to shade up to the x-axis. So I'm going to take this little gully here and I'm going to shade up to the x-axis. And then after 5, the graph dips below the x-axis again, so I'm going to shade up to the x-axis. And basically, I want everything on the x-axis that's included here. Let's not forget that this here is -infinity, this over here is positive infinity as far as the x values go. And this shading can keep going and keep going and keep going, right? So I need to begin at -infinity with an open set of parentheses, and I have to stop at -7. But I'm going to include -7 in my answer, so I want a bracket. And then I have a singleton point, this -4 right here. So open bracket, -4, -4, close the bracket, and that is the singleton point of -4, x equals -4. And then I have a whole bunch more over here that's all blue. Union, I start again at 0 and I include that 0, that's why we have a bracket. And I'm going to go all the way to positive infinity up here and close that with a set of parentheses. And I'm done with that question. So hopefully everything is making sense to you. I think it sounds pretty good. I'm going to go on to 7 and 8. Let's name them 7 and 8 first. Okay, this is question 7. This is question 8. Again, you can pause the video and try it all by yourself for a moment. Or not. You can come back to me. Okay, so I'm looking at f of x is greater than 0. This means that the y value has to be greater than 0. Y greater than 0 means strictly above the x-axis, which means the points on the x-axis do not get included this time. So I'm going to come back to my blue highlight. I'll make sure I got a small point here. Okay, I got a small point. And I'm going to write open circles around anything that's actually on the x-axis so that I do not include those in my final answer. Those are omitted from the interval that I'm going to be given as my final answer. Okay, and now I want to shade anywhere above the x-axis. So I'm going to shade this high point here. Shade this high point here. I'm going to, oh, I don't have anything else to shade. Nothing else is above the x-axis. So I'll go back and color a little more because I like shading. All right. So if I were to take those values and come down and shade the x-axis where those humps are, I would have a shaded area here and another shaded area here. And I don't think there's anything else I can shade because everything else is down here below and below. And I don't want to include anything that's below and below, only the above part. So starting from all the way over here on the left, I have to begin at -7. Oh, I have to change my marker to be a pen. So I am going to start at, did you see that? I almost put a bracket. I'm going to start at -7, but I do not want to include that. So I'm going to start with open parentheses, comma, and all this nice blue shading happens all the way until -4, but I cannot include the -4. Union, and now I do have another section immediately after the -4, so -4, comma, 0 is where I stop again. I do not include that 0. And of course, nothing after that is included either. I might want to think I want to include the 5, but I can see that big open circle, so I'm not going to include that 5. So I'm finished with that problem there. Question number 8 now is looking to see where f of x is less than 0. That means my y values have to be less than 0, which means I'm dealing with strictly below the x-axis. And again, I cannot put solid dots on the x-intercepts because those points are where the y value equals 0, and I don't want it equals 0. That was in the previous questions, numbers 5 and 6. So here, big open, oh, I want my other thing here. So I want a big open circle, open circle, open circle, and open circle. Do not include those values on the x-axis. And now I want values that are less than 0. So the only places where I can see that this graph is below the x-axis is right over here to the left. And you know what? I want a bigger. There you go. Over here, including that arrow. I also think I'm a little too big there. Also want this section below the x-axis. And I want this section below the x-axis. Problem is I can't include that 5 right here. I almost called it negative, but it's not negative. Can't include that -5 at all. So if I were to shade to my x-axis, starting over here on -infinity, I would be shading this. This graph continues to come down, and therefore this continues to shade. Over here between 0 and 5, I need to shade up to my x-axis. Not at 5, but after 5, I continue to shade because the graph is continually below the x-axis. All right, so if you just look at your x-axis here, you've got 1, 2, 3 sections that need to be named. Okay, this over here is of course your -infinity and your +infinity, which I don't name on all the graphs because I don't have a purpose for, but here I do. This graph is going to start me at -infinity, this domain, for which the function is less than 0. Starts at negative infinity, goes all the way to negative 7, but does not include that negative 7. I don't need to mention the fact that negative 4 is not included. I'm going to start at 0 because the shaded part gets infinitely close to 0. So union, open parentheses, 0, comma. I'm going to go all the way to 5, but I cannot include that 5, so I have to stop to omit it. I got to start right back again at 5 and go all the way to positive infinity, which you can write a positive sign if you want, or you can just write infinity. So these are questions 1, 2, 3, 4, 5, 6, 7, and 8. Not quite sure. Let's see. There has to be a way to do this. Let's see. Yeah, I'm not quite sure. I would like to like squish the whole thing and get it all looking really small for you, but I'm still new at this thing, so I don't know how to do that. But let's take a peek here. Questions 1 and 2 for greater than or equal to and less than or equal to. Notice the brackets that we have as part of our answers, because the points that are on the x-axis are included in your x intervals for which the y value equals 0. Questions 3 and 4. Notice the x-intercepts, or the points on the x-axis, are not included in any of your answers. And we have no brackets in any of our intervals. And now we're back to 5 and 6. See all those brackets again? Because I have the equal to 0 as part of my interval. And 7 and 8. Notice all the parentheses, no brackets whatsoever, because your inequality doesn't have an equal sign. All right, I hope this helps you get through the first couple of worksheets. Give me those domain intervals. All right, good luck, people. Talent out.